What's the first question I'm asking you about?
Okay. The diagram shows part of the curve y equals 8 minus square root 4 minus x, and the tangent of the curve at p3 and 7. Find the expression for the derivative and...
Okay, that's the integral, okay, with that fancy notation. Right, so the focus here is on what section?
The derivatives and integrals.
Yeah, but the application of it, okay, because they've given you a graph, so you can find the tangent of that graph, okay, depending on what you've got. Okay, so the diagram shows the point or part of the curve, actually. Okay, so we know that y equals 8 minus square root 4 minus x is a semicircle. Okay, part of the curve. Okay, so it's a curve, and the tangent to the curve at. Right, so the tangent to the curve. So there's the curve. The tangent is that line that goes through a point on the actual curve, which is 3 and 7. Okay, the first part of the question, so part 1, says find expression for dy over dx. Okay, so the first thing is find the expression for dy over dx. So we're deriving a derivative from the function. So the first thing is we need to write down the function. So y equals 8 minus square root, open brackets, 4 minus x, close brackets. Okay, so that's what we've been given as the function. Okay, so we need to derive this function. So we're looking for this, the dy over the dx. That's what we're looking for. Does that make sense?
Mm-hmm.
Okay, so is that bracket, is that root sign for the whole thing, eh? I take
sure.
it.
I think so.
Yeah, I think it's probably for the whole thing, yeah. Okay, so if you've got square root bracket 4 minus x, do you agree, can I derive a function as it stands? No, I can't. Okay, so I need to rewrite this like this. 8 minus brackets 4 minus x, close bracket, to the power a half. Okay, because when I have a square root, I can write it to the power a half.
Okay.
That's possible. Right, but now you've got a bracket and you've got the exponent. Right, can I multiply this bracket out? No, I can't with a half. Okay, so it's problematic here. This is the problem. Okay, you've got a bracket. But I can substitute. Okay, so I can make, so let bracket x minus x equal, let's just call it a u, or let's use a different variable. Yeah, let's use u. Okay, they normally use u when they use the substitution. Okay, so a u. Right, so now if I make that x, 4 minus x, a u, I can then derive a function for that. So then I would have what? Well, y equals 8 minus u to the half. Okay. Right, so now if I'm looking for a derivative, they call this the chain rule. We actually weren't supposed to cover it. It wasn't given in the work program.
The assignments are always harder than the papers.
Yeah, but they cover the chain rule, which I want to show you in terms of a reference. I didn't see that referenced here. What section was it in? Differentiation, second derivatives. Yeah, chain rule. page 190. Okay, see, this is extending differentiation. Okay, it was chapter 12. So we just looked at the normal differentiation, but here they're testing something from chapter 12, which is a chain rule. So it's linking, it's building on the derivative just by taking an expression and substituting something in. Okay, like what we've done there. We've made 4 minus xu, and then we've substituted in. So if we go to page 190, maybe you can write this to your, add this to your notes actually, just in case. Okay, it wasn't specific in the work program, but it's worthwhile making a note for it, just in case it comes up again. Okay, so you can just put a heading chain rule for differentiation. That's what it's looking at. See, even in the textbook they do the same thing. They show a substitution. Okay, so that's all it is.
So when you say chain rule?
Yeah, chain rule is just a substitution. Okay, we'll do one example.
Chain rule for
differentiation. Okay, and you can say, underneath that you can just say, required when we have a bracket raised to a power. Okay, the only reason why I'm using chain rule here is because I've got a bracket raised by a power. Okay, so that's when you apply it. Right, and that's why I'm looking at this particular page in the textbook. Okay, so let's do an example just to show the process in your notes. And then we can go back and do this example, the one in the assignments.
Okay, so example.
Right, so the example says, find dy over dx when y equals brackets 1 plus x squared close brackets to the 3. Okay, so notice you have a bracket raised by a power. Right, so what must you do? You need to derive a function using that chain rule, which is as follows. Okay, so there's no, they sit here. Okay, this is multiplying it out. There. Okay, substituting du. Okay, so you can say, using chain rule, let u equals 1 plus x squared. Okay, so what are we doing? We're taking that bracket 1 plus x squared and we're making it u.
Using chain rule?
Yeah, using chain rule, substitute u equals 1 plus x squared.
U equals?
1 plus x squared.
Okay.
Okay, so the next line, maybe let me write this down here. Okay, so this is the example from the textbook, page 191 to 192. Okay, the key chain rule. So far you've written u equals 1 plus x squared. Okay, because they asked you to derive the function bracket 1 plus x squared to the power 3. Okay, so what did you do? You made a u substitution in terms of chain rule, and you basically put that into there. Okay, so now you've got y equals u to the power 3. Do you agree?
Yeah.
Okay, so is it possible to find the derivative of this? Yes. Okay, dy over du would equal what? What would the derivative of this be? 3u squared. Do you agree?
Yeah.
Okay, so 3u squared would have been the derivative. Okay, but then we need the at the end point. Okay, because this would have been dy equals u to the 3, and then we need a du. So this function here, okay, can we derive that function? Yes, we can. Du over dx would equal 2x. Okay, so we had the substitution, find the derivative for both. Right, and then all we have to do now is look at this. Have a look. You've got dy over du, and you've got du over dx. Okay, what happens if I multiply those two together? What will cancel out if I multiply those two together? So du over dx times dy over du, what does that give you? What can you cancel? The du with the du. And that lands up with dy over dx. And see, that's what I wanted. Okay, I wanted dy over dx because this was the question. Right, so all I need to do now is show that multiplication. Okay, so du over dx times dy over du equals. Okay, so what is my du over dx? My du over dx was 2x, and I'm multiplying that by the 3u. Okay, what was the u representing? The u was representing that, the 1 plus x squared. Okay, so this would have been 3 times, so bracket within the brackets, 1 plus x squared, close brackets, squared. Okay, so can I multiply this out? Well, the 3 I can multiply out with that. Okay, so I'm left with 6x bracket 1 plus x squared to the square. That. Okay, and that's the end. Right, so dy over dx would be 6x brackets 1 plus x squared to the 2. Right, so that's just the example. Right, and I will obviously going to apply what we just covered now, but that's something that we needed to just check and remember. Well, I think chain rule was actually asked last year in the differential. We did something similar, I remember. Okay, but at least you have a note again for it. Well, so the reason why you're substituting this and this in is to eliminate the bracket within a bracket, that's all. Okay, so what are we going to do here? Same thing. Step number 1, differentiate both. Okay, so let's find dy over du, and let's find, where's my substitution? Oh, my substitution's over here. Okay, and let's find du over, dx over du. Because we're differentiating u in terms of x. So dy over dx, yeah, that would have been the other way around because you would have written it this way.
Okay.
Okay, so you would have written it like this. U equals 4 minus x. That's what you would have written. Then you would have written du over dx, which is the derivative of this. There's no derivative for the 4. Derivative of minus x minus 1.
Yeah.
Okay, so there's the derivative. Okay, now we need to find the derivative of this. So this, in terms of u, will be negative a half u to the minus a half. Okay, that's the derivative for that.
Great, then let's just write this out properly.
Okay, so I found the derivative for this one. There's the derivative for that one. And then I found the derivative for this one. There's the derivative for that one. Okay, and then we're going to highlight these two. Okay, then I'm going to multiply the two together. So dy over du times du over dx. The u's are going to cancel, and then you'll be left with dy over dx. So I need to write down both. Okay, what is the u? 4 minus x to the minus a half, and then times it by minus 1. Okay, so the only thing the minus 1 is going to do to this is change the sign. Okay, so it'll be a positive, so a half 4 minus x to the minus a half. Okay, that's dy over dx. Okay, there is a better way of writing this out because we don't like negative exponents, eh?
Yeah.
So you could write this down as this: 1 over 2 root 4 minus x. Okay, that's the better way of writing out that brackets. And that's it.
Okay, cool.
Okay, then we need to look at the integration. So the next part of the question, okay, so we've got the derivative. They said find the derivative, and now they need to look at the differentiation, not differentiation, the integration as well. Which chapter was that? Let's check. Yeah, integration. Okay, 269. Okay, 269 looks at the integration. Okay, but now here we've got this fancy thing, with the bracket again. So there's two methods that are mentioned here. They're looking at the plus k. So it's actually a guess. It's using the result in the shaded box. Method 1 or method 2. You have to basically apply what you've got in terms of the working. It's similar to chain rule, but it's not because it's integration. Okay, so there is a slight consideration here that you have to provide for in terms of the next part. Okay, so that's the one answer for what? The derivative. There's a derivative.
Yeah.
That's what it is. Okay, there, that's what it is. Okay, so now let's do the integration part. So it's still question 1, number 1, except they want you to find the integral. So integrate the y, which was what? 8 minus square root 4 minus x. Okay, dx. Okay, that's what they're asking you to do. Okay, so the last part of this question is to find the the function, but from the, so it's basically to take this and to build a function from it, not to derive it. Okay, so what must you do? We need to write this down as this. Okay, so do you agree, in terms of the 8, all I'm going to do is add an x there, yes?
Yeah.
Okay, but it's the second part that I need to worry about. So let's rewrite this as this. Not minus a half, it's a half. Okay. Right, so if I'm going to integrate this, I'm going to have to, here they say, let's see, differentiating this, you obtain that times by 2, therefore. Okay, so in other words, they're saying, in their example, is if you integrate, you're going to minus a half. See, if you look at this on page 269, they said method 1. The first guess at that would have been this, differentiating that, you obtain that. Therefore, you've got that. Okay, so it's like there's no set rule here. You just need to think about how would you get the actual answer from it? So now if I'm looking at this question, I've got a power half here. So if I'm integrating this, okay, it's going to be brackets 4 minus x to the 3 over 2. Okay, so if it's 3 over 2, what they've said here is that if I multiply this out, I'm going to get 3 over 2 bracket 4 minus x to the power of half, okay, times minus 2. Well, in this case, it wouldn't be minus 2, it'll be minus 1, okay, because this is the root of that. So then that gives me negative 3 over 2 bracket 4 minus x to the power a half. Right, that's what you've got there, okay, because you're multiplying it out. So that's what they're saying. So they say if you differentiate this, the 4 minus x squared, the derivative is that 4 minus x to the 3 over 2. Right, because if you multiply it out, you're going to get that answer, okay, which is the 4 minus the 3x squared. But what do I want? I want to eliminate the, okay, so I want to eliminate that. This is what I want to eliminate, because you don't want, this was minus 1, so then this will be times, so you'd be timesing that by 2 over 3, okay, negative 2 over 3. Because if I multiply this by negative 2 over 3, it's going to cancel that, and I'm going to be left with 4 minus x to the half. See, then that's correct. Okay, so they're saying use the guess to check that you can get that derivative. So then, that was the working for that little bracket there. Okay, so now if I'm looking at the integration here, the function here would be y equals, okay, so the 8, what would the integration be for that? 8x, okay, and then would it be plus or minus? Let's see, if the sign is, it was plus there, that was the negative, so it would have been the minus that, so negative 2 over 3 brackets 4 minus x close brackets to the power 3 over 2 plus c. Okay. And that's that answer. Okay, I was referencing the example on page 269, just in terms of this working.
Okay, done.
Yeah. Question 2. What do they want?
Find the equation of the tangent to the curve at P in the form of y equals mx plus c.
Yes, alright, so the tangent is the straight line, eh?
Yeah.
Right, so you know the tangent has an equation y equals mx plus c. That's obvious. Right, so all we need to do is get the gradient and get a c value. Okay, do we know what the derivative is? Yes. Okay, so use your answer from the previous question. Where did we write it down? Here's it. Okay, so dy over dx in this question was 1 over 2 root 4 minus x. 1 over 2 root 4 minus x. Okay, that's what we've got. Okay, you have the derivative. Okay, the function f of x, let's say, f dash x. Okay, they said the point that was given was what? So let's go back and read. 3 and 7. That was the point that was given. Okay, so when we covered this, just to go back in the textbook, you would have seen, where's the application? Here. When we did integration, we said that the integration can give us the gradient. Yeah, here, t. Finding the gradient. Tangents and normals. Okay, so we derive the function, and then we need to substitute in the 2. Well, in this case, the 3. Right, so if I plug in the 3 into the derivative, that gives me the m. Okay, so step number 1 is to get the m. How do I get the m? Substitute in. Okay, 4 minus 3 is 1. Root 1 is 1, so it's a half. Okay, so do I have the m? Yes. That's the m. Okay, m is a half.
Okay.
Right, so how do I get the equation of the straight line? Well, I need to complete the straight line formula. Okay, so the straight line formula was y equals mx plus c. Okay, you know what the m is, and you know what the value of the point is. So substitute the point in. 7 equals a half. Brackets 3 plus c. So 7 minus 3 over 2 equals c. Let's see, what is 7? 7 will be 14. 7 I can write as 14 over 2. Okay, so 14 over 2 minus 3 will be 11 over 2 equals c. Okay, so now I know what c is. Okay, so the last step is just to get the right formula. So now I can say y equals a half x plus 11 over c. Not c, 11 over 2. Okay, and if everything's over 2, I can multiply everything by 2. So 2y equals x plus 11. You can write it down as is. And there's the equation of the straight line. Okay, I think you could have left it as that. I think that would have been fine. Okay, but obviously it's a common denominator of the 2.
Okay.
Right, and then the last part of this question asks you to calculate the area, okay, of that shaded region. Right, so what must we do? We need the integration for that. So integration for the y of the dx, okay, is going to give me the thing, but from 0 to 3. Okay, why from 0 to 3? Because this is a graph. Okay, that's a Cartesian plane, right? So the first point is 0, and then the last point is 3, because that's the point 3. It's from 0 to 3. Does that make sense? Okay, so I'm just reading off the graph. Okay, we don't have to do all of that again because we've done it here. There, I'm going to take this. There's my integration formula. So using question 1.1, y equals, let's write it down, what is it, 8x minus 3 over 2 over 3 actually, bracket 4 minus x 3 over 2 plus c. Okay, so that was the answer that came from a previous question. Now, so I don't need to redo the integration, we've done it already, I just need to use it. Okay, so what am I going to do? I'm going to use these two values and I'm going to substitute in. Okay, so the notation would have been written like this. Okay, from 0 to 3. Okay, so how do I do this? I put in the 3 in and I put in the 0. Okay, so that will equal bracket 8 times 0 minus 2 over 3 bracket 4 minus 0 close bracket 3 over 2 plus c. There's the first bracket and then minus the second bracket. Same thing. Oh, be careful, I put in 0 for the first one, I should put that for the second one. Sorry, these 0s should have been 3s. Okay, remember it's the big number minus the small number. Okay, then I can write that other one here. 8 times 0 minus 2 over 3 bracket 4 minus 0 close bracket to the 3 over 2 plus c. Okay, then you're going to need the calculator to work this out. Some of it I can do, but I'll need help with the rest. Okay, so 24, 8 times 3 is 24. Okay, what is this on the calculator that you're going to have to plug in?
Okay, is it just type the whole thing in?
Yeah, well, just type this part in. So what is minus 2 over 3 bracket 4 minus 3 close bracket 3 over 2? What does that equal to? To the power of 3 over 2. Does it give you?
Minus 2 over 3.
Okay, that was actually quite easy. Minus 2 over 3. Okay, plus c. I'll close that bracket. Okay, so obviously 8 times 0 is 0. Okay, this you have to plug in. That might not be 0. It probably won't be because it's a 4.
Minus 16 over 3.
Minus 16 over 3. Okay, minus 16 over 3 plus c. Okay, and then the last step is just to work out the final answer. Okay, so I'm going to have 24 minus 2 over 3 plus 16 over 3. Okay, because this plus c and that minus c disappears. Okay, so it's literally just work out the next step. So on your calculator, 24 minus 2 over 3 plus 16 over 3.
Plus
16 over 3 equals what?
86 over 3.
86 over 3. Okay, and that's the end. Okay, so 86 over 3 represents the area under the curve. Okay, which is what we looked at. Yeah, you've made some good notes there. the highlighting all. Okay, so this is application. It's taking the derivative and the integration and applying it to a scenario, okay, to a question. Okay, so just remember the basics. Derivative gives you the gradient, integration gives you the area under the curve, right? And then just a little bit of differentiation and integration.
Okay.
Okay, so not too bad. That's the first one.
Okay, question 2.
Yeah, what's 2 asking you to do? Okay, new question. Okay, this one's a short one. Well, quite a few steps, but not a long question. It's actually a nice one.
The equation of a curve is such that d2y equals 2x minus 1, given that the curve has a minimum point at 3 minus 10. Find the coordinates of the maximum. Okay,
so we need the min and the max. Alright, so let's discuss that again. So remember we did theory. What does the first derivative do? F of x gives you what? X values for points. Do you agree? Okay, the second derivative, f dashed x, tells you this is positive or negative, if it's a min or a max, so happy or sad. Okay, that's just the revision. Okay, so the first derivative gives you the point, the second derivative tells you if it's a min or a max.
Yeah.
Okay, so what did they give us in the question? The second derivative. So let's write it down. What is the second derivative? d2y over d2x, or dx2 is what? 2x minus 1. Okay, that was given in the question. Given that the curve has a minimum point at, okay, minimum point, so they tell you there's a min at what point? 3 minus 10. That's what they tell you. Okay, that's what they give you in the question. Yeah, that's what they're giving you in the question. Find the coordinate of the maximum point. Right, so that was what was given. Okay, 2 bits of information. You were given this, a minimum, and you were given this, a second derivative. Okay, so do you agree? What does the second derivative do? Tells you if it's a min or a max. Okay, so I'm just going to show you theory. If I take this 3 and I plug in the 3 into here, okay, the second derivative, so dy2 over dx2 is going to equal 2 bracket 3 minus 1, which is 6 minus 1, which is 5. Okay, if it's a 5, it's happy or sad? Happy. Okay, so is this a min or a max? It's a min. Does that make sense? Okay, so that's what they've told you. Minimum at 3 minus 10. That's what they've given you. Okay, so how am I going to get the points? Well, do you agree the first derivative gives me the 2 points? Gives me 3 and something else. So how do I get from the second derivative to the first derivative? Am I going backwards or forwards? I'm going backwards. Okay, because, let me show you this. We start with the function. So y equals x. Second step would be dy over dx. Third step would be dy2 over dx x2. Second derivative. Okay, so first derivative, second derivative. Okay, what am I doing? I'm going from second derivative back to the first. So is that integration or derivatives? Integration. Do you agree? Okay, so I need to integrate this. Okay, so f of 2x minus 1, that's what I need to do, dx. Right, so what does integration say? Write down the 2x, 1 plus 1, all over 1 plus 1. Okay, and I've got a minus 1 here, so then minus x. Okay, so if I simplify that, 2 over 2 is 1. So x squared minus x plus c. There's the first derivative. Does that make sense? Okay, so if you had to derive a function from here, the derivative of x squared minus x is what? 2x minus 1. Does that make sense? Okay, so now you've got the first derivative, so the dy over dx.
Okay.
Okay, we need to go back and get the main function. Okay, so there's one step further, we need to go back. So now we've got the first derivative, that's the first derivative. Okay, so first derivative is dy over dx is x squared minus x plus c. Okay, that was the second derivative. So now I want the function. Alright, so integrate okay, so what does that give me? Well, same story applies. I'm going to put in the extra step. 2 plus 1 over 2 plus 1 minus x 1 plus 1 over 1 plus 1 plus c. Okay, so now I know what the function is. The function is x to the 3 over 3 minus x to the squared over 2 plus c. There's my function. There's my y equals. Right, so what do I know from the question? I know that I have a point that has the value. What is the point? P, hey? No, they didn't label a point. Okay, so we'll just call it points. Okay, what is the point? 3 minus 10. Okay, so if you substitute an x in here, you get a y. Do you agree? Okay, so let's put that in. So I'm going to have minus 10 equals 3 to the 3 over 3 minus 3 to the squared over 2 plus c. Can I solve for c? Yes. Okay, so let's work out c. Minus 10 equals root 3 over 3 is 9 minus 9 over 2 plus c. Okay, so minus 10 minus 9 plus 9 over 2 equals c. Okay, can you type that into the calculator? Let's see if we get a c. C is?
Minus 29 over 2.
Minus 29 over 2. Right. Sure about that?
Yeah.
Just double check. Minus 10 minus 9 plus 9 over 2. Minus 10 minus 9 plus 9 over 2. Okay. Okay, perfect. So then we've got that. Right, so what can I do here? I can write that in there. Okay, so let's summarize. Let's write down all the answers we've got. Okay, first answer is the function y equals x to the 3 over 3 minus x squared over 2. Now I know what the c is. Minus 29 over 2. There's the function. Okay. Right, so first derivative, dy over dx is going to be times the 3, so it'll be times 3 by a third, which drops it, so x squared, times that drops it, so minus x. See, there's the first derivative. Okay, constants fall away. Right. And then, what do I do to find the middle of the max? I make this equal to 0. So, derivative equals 0. X squared minus x. 0 equals x, bracket, x minus 1. Okay, so x can equal 0 or x can equal 1. Are you sure the C is right? This, to me, I'm a little bit worried about that. Let me just check. Okay, let me just check the working. Well, what is 3 to the 3 over 3? What is 3 over 3 over 3? Is it 9? 3 squared over 3 is what?
That's 3 to the 3.
Yeah, 3 to the 3 over 3. What is that?
3 to the 3.
Over 3.
Over 3.
What is that?
9.
Okay, it is 9, so that's fine. And then 3 squared, 3 times 3 is 9. 9 over, okay, so that is right. And then I took it that side. Oh, there's my mistake. Okay, when I take this, that side, it becomes a plus or a minus. It becomes a minus. Oh, it is right. Yeah, because it's plus here, it's minus there. So if we go to that side, it's minus plus. Yeah, it is correct. Okay, just checking. It looks strange. Okay, but anyway. Alright, so that's that. So second derivative, dy2 over dx2 would have been 2x minus 1. Okay, that's what we had earlier, hey? Yeah, there. See, 2x minus 1, we had that. Okay, but I see they've already given you the minimum. So they've given you the minimum, they've given you one of the points. They haven't given you the other point. But then you don't know what the C is because the C would have fallen away. So if we've got dy over dx equals 2x minus 1, yeah, that is right. And then they've given you a point. They've given you the point, so you know, but you wouldn't be able to get if this was minus x, because the second derivative is x squared minus x. We had that, hey? Yes, here's it. There's the x squared minus x. There, x squared minus x. So it is right. Just the plus c. Okay, remember the plus c is a number that we don't have. Okay, so we've got 2 points that we need to test here. Okay, we've got 0 and we've got 1. Okay, so what we're going to do, plug that into the second derivative. Okay, so 2 bracket 0 minus 1 equals 2 minus 1 is 1. So that's happy. Okay, and then the other one was 1. So 2. Oh, no, hold on. That's minus 1. Minus 1, not plus 1. Okay, because 2 times 0 is 0. Sorry, mistake. 2 times 0 is 0. 0 minus 1 is minus 1. Okay. Right, then if I put in a 1 here, then here I get 1. Okay, that's happy, that's sad. Okay, so they wanted what here? The maximum point. So there's the maximum points. Okay, so maximum at x equals 0. Okay, so I need to plug in 0 back into this equation. Here's my function, see? Okay, so I plug in 0 here. Obviously it's easy, 0 falls away, 0 falls away, you're left with the constant. Okay, so the y would equal 0 plus 0 minus 29 over 2. Okay, so the max is at brackets 0 and minus 29 over 2. That's where the maximum is. Yes, I'm just working backwards or forwards depending on what I'm asked for. Okay, so if I've got the function, to go forward, I need to derive to get first derivative, second derivative. Okay, if I'm going backwards, then I need to integrate. Okay, remember it's a whole forward or backwards thing. Okay, we did examples in the notes last week about that. Okay. Right. Another question completes. How are we doing? Still okay?
Yeah.
Alright. Let's do one more then, and we can take a little breather. Right, this one is for 8 marks again. Okay, they're quite long, these questions. There aren't too many, but they're quite long in terms of the workings. Okay, so question 3. Right, again, focus is important. You tell me what they're asking you to do.
The diagram shows the curve y equals minus x squared plus 12x minus 20.
Okay, they've labeled that.
Y equals 2x plus 1.
And they've labeled that.
Find, showing all necessary workings, the area of the shaded region.
Perfect. Okay, so what are they asking you to do? Work out what that area is. Do you agree?
Mm.
Okay, so you've got 2 different equations. Okay, you're asked to work out the area of that bit there. Okay, so area under the curve. But you've been given 2 of them. So let's reference the notes again. Okay, this is integration. We need the formula for it first. There. Okay, so page 254. Okay, when you have 2 functions, I think you just minus the one from the other. But let's just double check. Because you've got one function, you've got another function. So you need a formula. It's there, the area algorithm. Find the area under the graph y equals f of x. Okay, that's fine. That's what we've been doing all the time. And now I want one with two graphs. See, these are all single graphs. Okay, here. We need one with a double graph. Here's a double graph. There we go. Okay, area between 2 graphs, page 267. Okay, this wasn't in the work program, but it's in the assignment. Do you want to make a note for it?
Yeah.
I think so. Okay, on a separate page, this is a theory note you can add to your integration. Okay, it's coming from the textbook, not the work program. Okay, so the assignment is asking you to cover it, so let's cover it. Page 267. Heading for this, area between 2 graphs.
Area?
Between 2 graphs. Okay, can you draw those 2 graphs? Okay, so one graph that does this and one graph that does that. Okay, let's highlight the middle points. Okay, so exactly what they've got here, this is a sketch. Yeah, so it is the one minus the other, but it's the integration.
What's that here?
That sketch. Okay, just to show the 2 graphs. And then you just write down that formula and then we write. Okay, good. Highlight that area between the 2 graphs. Just label them. The bottom one is g of x, the top one is f of x. Okay, f of x at the top, g of x at the bottom. Okay, so highlight the middle bit. No, the graph will obviously extend. Highlight the middle bit. That's what you're looking at. Okay, so it is just the minus. It's just subtracting the one from the other. Yeah. Okay, then just write on this formula here. There's it. Okay. Write on that formula. That's the equation. Okay, so it is the one minus the other. Yeah, I thought it was. Yeah, so A2B. Yeah, the bottom one. Yeah, don't worry about the top one. The top one is just, it looks complicated because it's 2 separate. That one's better to do. f of x minus g of x. Okay, top equation minus the bottom equation. And then integrate. Right, so let's apply that to this question. Okay, let's go back to the question. Here's it. Let's write down the two functions. Okay, so I'm going to label these functions. F of x. I'm going to label f of x this one. The top one. Where's the top one? Is the top one the parabola or the straight line?
Top one is the parabola.
Exactly. So this is going to be minus x squared plus 12x. Okay, minus 20. Right, the reason for that is because you've got this and you've got this. Okay, the f of x is the top graph. The g of x is the bottom graph. Okay, so g of x is equal to, what is g of x? 2x minus 1. Is that right? Let's just double check. Y equals x squared plus 12x minus 20. Yes. 2x plus 1? Yes. Okay, good. So what would this area be between the two graphs, i.e. this part? The graph is in your actual question, so you have to redraw it. I'm just showing it here. So the equation would be integrate f of x minus g of x d of x. Okay, so this equation minus that equation. So integrate x squared minus x squared plus 12x minus 20 minus g of x, so minus 2x plus 1. Okay, a negative of a positive is a negative, negative of a negative is a positive. Okay, d of x. Okay, so that gives me f of minus 2x squared, x squared, plus, okay, so plus 12x minus 2x is plus 10x. Minus 20 plus 1 is minus 19. There we go. Okay, and now I can integrate that quite easily. Okay, so the next step would be to integrate that. I'm going to do that on the next page. Okay, so what do? I write down that, so minus x squared minus x squared. Okay, what do? I add 1 and I divide that by 2 plus 1. Okay, that was the first one. Minus x squared, add a 1 over 2 plus 1. Okay, then the next one, here's it. Plus 10x. So plus 10x. 1 plus 1 over 1 plus 1. Okay, and the last bit was 19. Okay, so minus 19, so that's easy. 19x. Okay, derivative of 19 minus 19x is 19. Okay, plus c. Okay, so let's neaten this up. Minus x to the 3 over 3 plus 10 over 2 is 5, so 5x squared. Minus 19x plus c. Okay, and what was I looking at? I was looking at 2 points. They give you those 2 points. They must, did they? No, they didn't. Ooh, so more working. Wow. Okay, this is a long one. Okay, so I want to show this quickly. My one is out of 8. Okay, it's a lot. Okay, it's from A to B. Okay, we don't know what the A is, we know what the B is. We can work it out. Okay, that you can actually try. But how do I get these 2 points? How do I get this point? How do I get that point?
You're substituting.
No, think about it. Okay, how do I get this point? And how do I get that point?
Yeah, the M in the
It's where,
gradient.
no, it's where those two graphs cross. Okay, where do you find a point of intersection? If two graphs cross, well, how do you find that point? The one equals the other. Okay, so here we have f of x equal g of x. Here we have f of x equal g of x. Okay, so in order to get those 2 points, we need to make those 2 equations equal. Okay, so what are the 2 equations? Y, so x squared plus 12x minus 20 equals 2x plus 1.
And it's just solve for x.
Yes, okay, that I think you can do. Okay, so you try that.
So should I move everything to the one side or first?
Of course.
The trinomial?
Yeah, you have to move everything to one side because you can't factorize if you've got things on both sides. Okay.
So now should I do this as a trinomial?
Yeah. Take everything to one side. No, take everything to one side. It must be equal to 0. Okay, everything needs to be on one side.
But now it's not a trinomial there. So now what do we do?
It is a trinomial.
But there's 4.
Yeah, so can't you 12x minus 2x is what?
Oh, I can do that.
Okay.
So now we go factors of 10, eh? Not 21. Factors of 21.
Ooh, see, this is that rusty bit.
Is the factors of 21 or 10?
Okay, so when you FOIL something, what must you do? You need to times the first and the last.
Yeah.
Okay, so it's the factors of 21. It's always the factors of the last one. Okay.
And then these numbers plus to give you that and times to give you that.
Yeah, to get the middle. Oh, hold on. There's a minus here. Be careful. It was minus x squared, hey? Yeah. Okay, so minus x squared. Okay, that does make a difference because now all the signs can change. Yeah, it was, let's just look at the question again. Minus x squared plus 12x minus 20 equals. Yeah, that's right. Okay, so then you've got minus x squared plus 10x minus 21. Okay, so how do you get rid of a negative? Times everything by negative. So this will become a positive. This will become a negative. This will become a positive. Okay, and in factorize that.
No, that's
Okay,
right.
so what can x equal? 3 or
7.
exactly. Okay, so do I have those points? Yes. So this point is 3 and that point is 7. You see that? Okay, that's the whole reason why we needed it. Okay, so the last step is just to do the calculation. Okay, plug it in to that. That's the last bit. Okay, so let's show that working. Let's write it down again. Minus x over 3 over 3 plus 5x squared minus 19x plus c. Okay, from 3 to 7. Okay, so what am I going to do? I'm going to plug it in. Minus 7 to the 3 over 3 plus 5 to the 7 squared minus 19 to the 7 plus c. Okay, minus 3 to the 3 over 3 plus 5 to the 3 minus 19 to the 3 plus c. Close brackets. Okay, and then we just need numbers for all of them. Okay, so let's do each one separately. Okay, we're going to FOIL it, well, distribute rather. Okay.
With the negative in.
Yeah, just now. That's the next line. Okay, so on your calculator, what is minus 7 to the power 3 over 3?
Minus 7 to the power of?
Minus bracket, 7 to the power 3 over 3.
So bracket minus 7 over 3 to the power of 3 plus 5.
Do it separately. Do it separately, it's better. You're going to make a mistake if it's too long. Okay, so what is this equal to? Minus 7 to the power 3 over 3.
Must I give you a decimal or
Fraction.
so it's minus 3/4 over 27.
Okay, plus this one, 49 times 5 basically. Well, 5 times 7 squared, what is it?
245.
Okay, 19 times 7.
133.
133. Okay, let's get rid of this bracket now. Okay, so negative times that. Okay, 3 to the 3 is 27, so it'll be 3 squared, which is 9, so plus 9. Okay, 3 squared is 9. 9 times 5 is 45, minus 45. Okay, 19 times 3, what is that?
27.
Okay, minus C. Right, last step. Add and subtract all the numbers. Okay, the C's drop away. Okay, so on your calculator, minus 343 over 27.
343 over 27, yeah.
Plus 245.
Yeah.
Minus 133. Plus 9. Minus 45. Minus 57. Gives you what?
170 over 27.
170 over 27. Positive or negative?
Positive.
Okay, so then that's fine. Right, and that's the final answer. So that would be the area under the curve. Okay, 127 over, not 127, 170 over 27. As a decimal, what is that? 6,29, yeah. Okay. Yeah, so quite a long one. Question 4. Okay, what does question 4 say? Solve the inequality, but now you've got these absolute value symbols. Okay, so absolute value means cannot have a negative. Okay, so 3x minus 2 greater than, let me just look at it the right way around. Okay, greater than, equal to x plus 4. Okay, so when you have this, what does that absolute value mean? It must be positive. Do you agree? Okay, so this must be positive and that must be positive. Do you agree? Okay, so because you've got the absolute values, let's look at the workings for the absolute values first. Okay, so you need to know that x to the 3 minus 2 must be greater than or equal to 0. Okay, because of the absolute value sign. So 3x must be greater than or equal to 2. So x must be greater than or equal to 2 over 3. Does that make sense? Okay, dealing with the absolute value stuff first. Okay, the other one's easy. X plus 4 greater than or equal to 0. So x must be greater than or equal to minus 4. Okay, now what? I need to look at both together. Right, so that's the first part, look at the absolute value. Second part, take this to that side. Okay, so I'm going to have 3x minus x minus 2 minus 4 greater than or equal to 0. Absolute value. Okay, so 3x minus x is 2x. Minus 2 minus 4 is minus 6. Greater than or equal to 0. 2x greater than or equal to?
What about the allowance?
6. It's absolute value. Absolute value means it must be greater than 0. So it's right. Okay, it must be greater than 0. Okay, positive, because the absolute value says get the positive number. X must be greater than or equal to 3. Right, makes sense. Okay, we've got all of those amounts, and now what are we going to do? Draw a number line. Test. Okay, so what points do I have? I've got minus 4. I've got 2 over 3. And I've got 3. Okay, let's test the points. Alright, so let's take any number that's less than minus 4. Any number less than minus 4, let's take minus 10. Okay, so if I plug in minus 10 here, what am I going to get? 3 times minus 10 is what? Minus 30. Minus 30 minus 2 is minus 32. So I've got minus 32 on the left here. On the right, I've got minus 10 plus 4. Minus 10 plus 4 is minus 6. Okay, is minus 32 bigger than minus 6? No, that's false. Okay, with inequalities, you have to do the test, so that's false. Okay, take any number between these two. Easiest number between negative 4 and 2 over 3, I think is 0. Okay, so let's put in 0 here. If I put in a 0 here, 0 times 3 is 0, minus 2. 0 plus 4 is 4. Is minus 2 bigger than 4? No, it's false. Okay, take any number between there. Let's just take 2. 2 is probably the easiest number to work with. 2. 6, well, 3 times 2 is 6. 6 minus 2 is 4. Okay, and then 2 plus 4. 2 plus 4 is 2. 2 plus 4 is 6. So we've got 4 greater than 6. That's false, also false.
So is all this red here the testing?
No, the testing is what I'm discussing.
Oh, so am I not writing it down?
If you want to write down, you're going to write down like 1, 2, 3 substitutions. Okay, so it's up to you. Do you want to? Show it then. Okay, so so what do I substitute here? Minus 10. Okay, so show what I just said. So I'm just reading it out. Okay, so what do I do here? Take any number less than minus 4. What did you take?
Minus 10.
Okay, so what do you do with minus 10? Plug it into that. Okay, so what do you get? What is minus 10?
3 minus 10.
Minus 2.
Minus 2.
Greater than or equal to? No. Minus 10 plus 4. You're testing. Minus 10 plus 4. Minus 10 plus 4. Good. Okay, so what is that?
So we're going to 3 minus 10 minus 2 is minus 32.
Okay, so minus 32 is on the left.
Minus 10 times 4 minus 4.
Not times. Minus 10 plus 4. True or false? Is minus 32 bigger than minus 6? No, false. That's why I wrote false here. Okay. Right, test with the number between there. What did I test with? I tested with 0. Okay, so plug in 0, what do you get?
False.
It's false. Okay, good. Minus 2 is not bigger than 4. Good. And then I took a number between there. I just took 2. It's a round number. It's easy to substitute. Is 4 bigger than 2? No. So you did something wrong.
3, 2 minus 2. Ratio of libertarian.
And it's +4, not +2.
Where? Yeah.
Yeah. Okay, so you've got 6 there. Is 4 bigger than 6? No, that's why I got false. Okay, so you've caught up. Let's do the last one together. Okay, you do it. Give me a number bigger than 3.
4.
Okay, let's plug in 4. 4 times 3 is 12. Minus 2 is 10. Okay, then 4 plus 4 is 8. Good, so is 10 bigger than 8? Yes, that's true. Right, so what do? We put the x, put your symbol, and then we can rewrite that. So final answer, what did they say? Solve the inequality. Yeah, so we're solving the inequality. Therefore, final answer, x must be bigger than or equal to 3. And that's number 4 completes. Okay. Can we push through and do the last one, or you?
Yeah, do the last one.
Sure. Okay. Right. Polynomial P of x is defined by that. Okay. This is looking at the factor and remainder theorem. Okay. It's a nice short one, not too bad. Well, the last one's a bit long, but the first one's easy. Okay. So, what do you remember by the factor and remainder theorem? Well, remember a polynomial can be split up into different what's the word? Factors. Okay, so question 5. Question 5 says, where a is a constant. So they haven't given you a, but they've given you the p of x. So let's write down p of x. X to the 3 plus 2x plus a. We don't know what the a is. Okay, then for point number 1, so question 5.1, they tell you that given that x plus 2 is a factor, if it's a factor, do we get 0? Yes, we do. Okay, so if x plus 2 is a factor, what does that tell you about the polynomial? Well, if x plus 2 is a factor, then we know that p of minus 2 is going to give you what? 0. Okay, because it's a factor. Okay, if it's a factor, if you substitute the minus 2 and you'll get 0. Okay, so let's write that down. 0 equals 2 minus 2 to the 3 plus 2 bracket minus 2 plus a. Right, so given that there, find the value of a. There we go. Find the value of a. So what is minus 2 times 3, minus 2 cubed is minus 2 times 2 is 4, 4 times 2 is 8. Negative times a negative times a negative. There's an odd number of negatives, so the answer is negative. Minus 4 plus a. Okay, so take that across, it becomes 12. So 12 equals a, or a equals 12. There's the answer. Okay, done. Easy, 2 marks. Okay, so all you had to remember there was that. The factor and remainder theorem. Okay, if it's a factor, you substitute something in, gives you 0. That's the knowledge that you need to study from the material we looked at last week. Okay. Alright, then the last question says, this is the last question, I hope. Yeah, okay, it's a long, well, relatively long. Not too bad, actually. Okay, then we've got 2 more. Okay, 5 is short. 6 is a bit longer. Okay, so 2. Happy with that?
Yeah.
Okay, last bit. Number 2. Second part says, when a has this value, find the quotient. Okay, quotient is when you multiply things out. Okay, well, not multiply, divide. Quotient is the divide. Multiple is multiply. P of x is divided by x plus 2, and hence show that the equation P of x equals 0 has exactly one real root. Okay, so quotient, find the answer. So we need to do long division here. Okay, so what is it? X plus 2, right? Okay, dividing that by x plus 2. What is the equation now? X to the 3, yeah?
Plus 2x plus 8.
Okay, but now we know what a is. Do you agree?
Mm-hmm.
Okay, x to the 3 plus 2x.
Plus 8.
A has a value now of 12 plus 12. Okay, that was from the previous question. Makes sense?
Mm-hmm.
Okay, so let's do the long multiplication. Okay, so I'm going to revise it if you forgot from last week. This is what you do. Okay, so what do? How many times does x go into x to the 3? How many times? 2 times. Do you agree?
Yeah.
Okay, so then I've divided. Second step, multiply. X squared times x, x to the 3. X squared times 2, 2x squared. Okay, then I bring down. Subtract first, then bring down. Sorry, skipped a step. Just follow the steps we had last week. Okay, subtract first, then bring down. Okay, well, it's going to get to the same answer anyway. Let's just show it properly. Okay, so if I subtract, I'll end up with 0 here, 2x squared. Then I'll bring down. Okay, how many times does x go into 2x squared? Plus 2x, do you agree?
Mm-hmm.
Because 2x times x is 2x squared. Does that make sense?
Mm-hmm.
Okay, so I've done the divide, now I do the multiply. 2x times x, 2x squared. 2x times 2, 4x. Okay, then I do subtract. 2x squared minus 2x squared, nothing. 2x minus 4x is minus 2x. Bring down, plus 12. Okay, how many times does x go into... hold on, did I make a mistake here? Let's just check. X goes into that squared. That times that is that. That times that is 2x squared. That's correct. Okay, then I subtract that minus that. Oh, here's the mistake. Should have been a minus here. Sorry, it's a minus. Okay, it's 0 minus 2x squared is minus 2x squared. Okay, so this sign needs to change. Because it's not going to work out. Right, so minus 2x squared times that gives you minus 2x squared. That's fine. Minus 2x times 2 is minus... So this also change the sign, please. Okay, it's that. Minus 4x. Okay, then 2 minus minus 4 is plus 6, so that needs to change. Now it'll work out. See, I can see it's not going to work out, so I need to go back and check. I made a mistake. Okay, that needs to be a 6. Okay, that's better. Alright, so now everything's correct up until there. Okay, how many times does x go into 6x? Plus 6. Okay, so 6 goes into 6x, 6x. 6 times 2 is 12. Land up with 0, that's what I want. Okay, so do I know what this polynomial is equal to? Yes, I do. Okay, so I can write that down. This is on a separate page or separate notes. Okay, this polynomial, x to the 3 plus 2x plus 12. X to the 3 plus 2x, what is it?
Plus 12.
Plus 2x, yeah. Plus 12. Okay, equals x plus 2 and then x squared minus 2x plus 6.
Can you just go? Yeah, okay.
Minus 2x plus 6. Plus 6. Okay, can I factorize the trinomial? Yes, that you should be able to do. More practice. Factorize it.
Which one? This one?
Yes.
We're doing 6.
Yeah, you need to get a 6 in the middle. That's a problem, hey? What did they say here? Hence show that the equation perfect has exactly one real root. We should be getting the same answer. Let's just check this again. X to the 3 divided into is x to the squared. Yeah, x squared times that is that plus 2x squared. That's correct. Okay, then that goes into there. Minus 2, yes. Minus 2x. Minus 2x times x is minus 2x squared. That's correct. Okay, then we brought down. Okay, then here we took out. So divide first. Yeah, that's fine. And then multiply out. Okay, so plus 6 times that is 6x minus 6x plus 12. Yeah, that's right. Okay, and then yeah, that looks right. It was 2x, eh? Yeah, x to the squared plus 2x. Plus 2x. Yeah, that's strange because if it's plus 2x, because they want a real root. So real root means we need to factorize that. But now see, that's a plus. The problem with that is if it's a plus, I think there's a problem with the sign. Because you can't get minus 2.
I had plus 2x here, but then I saw you had minus.
Let me do it on paper. Can I use a pen? Let's check this. Let's check the long division. I think the long division has a problem. Okay, so x to the 3 plus 2x plus 12. Let's check this. X plus 2. Okay, so that goes into there. X squared times x to the 3 plus 2x squared. Close brackets. Minus. That's minus. It'll be negative 2x squared. Bring down. Plus 2x plus 12. Fine. Okay, so that goes into there. Minus 2x. Minus times that is minus 2x squared. Minus 4x. Okay, substitute. Minus and minus is naught. 2 minus minus 4 is plus, is 6x. Plus 12. Okay, that goes into there. Plus 6. 6 times x is 6x. Plus 12 is 0. Okay, no, it's perfect. There's nothing wrong with the long division. Okay, so that gives you x to the 3 plus 2x plus 12 equals brackets x plus 2. And then brackets this thing, x squared minus 2x plus 6. So if it's a minus 6 here, minus 6. No, it's a plus 6. It's a plus 6. That means you're multiplying.
The only factors of 6 is 1 and 6 and 2 and 3.
Yeah,
so
no.
you're not going to get the answer of 2 from those.
Yeah, you can't get a minus 2. Yeah, that is the problem. So the thing is, you can't factorize this. Okay, so let me just write that here.
Isn't there that formula if you can't factorize?
Yeah, then you can get, but then that's not a real root. Okay, but that actually is in line with the question. So that's actually correct then. So have a look. Okay, do you agree? This gives you minus 2x plus 6. Okay, so in other words, this not real roots. Okay, so the only real root that you have, see exactly one real root which is correct, because then this is x equals minus 2. Okay, this is the one real root. Okay, is it possible to factorize x minus 2x plus 6? No, you can't, but then you can use the quadratic formula. So I want to show those other roots just in case, because this is out of 5 marks. So I do think you need to show that as well, just in case. So let's show that. Okay, the quadratic formula is x equals, I can't really remember it. I think it's minus, is it minus b plus minus square root b squared minus 4ac. I think that is it, eh? Quadratic formula. Okay, we're going to use the quadratic formula. Let's just find it now. I hope this textbook has it. The quadratic equation 57. Should have bought the other textbook. Here's it. Okay, it is in the textbook. That's fine. Yeah, minus b plus minus square root b squared minus 4ac over 2a. Okay, so that's going to equal minus b. So b here is 2, so it'll be a 2 plus minus square root. Okay, so b minus 2 squared is 4. Minus 2 squared is 4. Okay, so it's 4. Minus 4 times a. A is 1. C is 6. So minus 4 times 6 is minus 24. Minus 24 plus 4 is minus 20. There you go. See, it's correct. Okay, over 2a, which is 2. Right, so there, that proves it. Okay, so then we can highlight this. Okay, you cannot square root.
Is that minus 20 or minus
minus 20? Minus 20. You cannot square root minus 20. On your calculator, let's just check the bracket again. Okay, so it's bracket minus 2 squared. Okay, minus 4 times 1 times c. C is 6. Close bracket equals, minus 20. It's correct. Okay, and therefore you can say here, okay, non-real. So that proves it even. Okay, you cannot square root a negative number. And therefore it's in line with the question, because the question says, show that it only has one real root. That's the only one real root. Right, and now we've completed the assignments. Happy?
Perfect.